This is Mrs. Gagnon. I'm sorry I can't be in class today, but I am going to do a video for you of the notes on the law of sines. So first, I'm going to start with a proof of where the law of sines comes from, and then in future videos, I'll do some example problems and some application problems. Okay, so here's how the law of sines works. The first thing I want to do is I want to start with an arbitrary triangle. This theorem works for all triangles, so we want to go ahead and just kind of draw a arbitrary triangle. Okay, I'm going to make it scalene and acute. Okay, so here's my triangle. Okay, I'm going to label these pictures. So I'm going to go and label this alpha. Okay, alpha is a Greek letter for A, and so I'm going to put a capital A for this side length here. Okay, and then I'm going to do, this is going to be the Greek letter beta, and this is a capital B here. Okay, so we're going to work with these two angles and see what develops. Okay, the next thing I'm going to do is I'm going to draw an altitude that drops down from here and is going to be perpendicular to this side right here. Now, I don't know what this length is, so I am going to just label this side X, okay, because it's unknown right now, okay? All right, the next thing I'm going to do is start to look at some relationships here. Now, if I look at beta, I have opposite over hypotenuse. So if you think about your SOHCAHTOA, okay? So you got your SOHCAHTOA here. What trig function is opposite over hypotenuse? Aha, sine function. So thus why it's called law of sines. Okay, so we're going to be able to develop an idea from this. All right, so the first thing I'm going to do is I'm going to say, okay, I can say that the sine of beta is equal to opposite over hypotenuse, so A over H. Okay, that's A over H. Then I can go over to this angle and I can say that the sine of alpha is equal to opposite over hypotenuse, which is X over B. Okay. All right, so now I'm going to put this X in green here. So this is in green and this is in green. So now I could solve for X on this equation. I get X equals, and I get X equals here. Okay. If I multiply this side of the equation by A, I get A sine of B. If I multiply this side of the equation by B, I get B sine of alpha. Okay. So now I can go ahead and state that since X equals this value and X equals this value, A times the sine of B is equal to B times the sine of alpha. Okay. And one more step to kind of just clean this up a little bit. I'm going to divide this side by A. Okay, and if I divide one side by A, I got to divide the other side by A. And I'm also going to divide by B. Okay, I'm going to divide by B, and I'm going to divide by B. Okay, so on this side, the A's cancel, and on this side over here, the B's cancel, and I'm left with the ratio that the sine of B divided by B is equal to the sine of alpha divided by A. Okay, so basically what the ratio is saying here is if I take the angle and skip this X for a second, if I take the angle, the sine of this angle and divide it by A, it is equal to taking the sine of this angle and the side opposite. Okay, so we're going to formalize on the next page what the law of sines actually says. The law of sines says the following. Okay, this is kind of a formal definition. We're going to state that the ratio between angles A, B, and C and opposite sides A, B, and C, respectively. Respectively means in that order. So it means that A is opposite A, B is opposite B, and C is opposite C in that order. We have the following equation. The sine of A divided by A equals the sine of B divided by B, which equals the sine of C divided by C. Okay, that is your law of sines. Now I will go into some examples on future videos.